Dear students, in the last class, we have learned about how to find the value of perfect cubes and properties of cubes. So today, we are going to study about prime factorization of perfect cubes.
So we need to find out cube root of a given number by using the prime factorization method. So already you got the prime factorization method by using the square and square root. So same concept will apply even to find out the cube root also. If you're not awareness about the prime factorization method, just see the square and square roots topic. You'll get clear about the prime factorization method. So I'm not going to discuss much more in this. So directly I'll come to the topic. So first we need to resolve the given number into prime factors. Right? For example, okay, I'll take question. Find the cube root of find the cube root of 9261. Next we'll see how to test the number to be perfect cube or not also. So anyway, we will use the prime factorization method for both. Now find the cube root of 9261. So we need to take 9261 and resolve this number into prime factors. So product of prime numbers. Make the group in triplet next. Now what you can take 3 table because it's not divisible by 2 next to 3. 3 3s are 9 and 0 8s are 24. Because of 2 digits you'll kept 0 here. 7s are 21. 3 table 1 so 3 0 2 is 6 and 9. Again 3 table takes 3 3s are 9 43. Now next prime number is 5. It's not divisible by 5. Next prime number is 7. So 749 is 343. Again 7 7 is 49. 7 1 is 7. So first step is we need to resolve the given number into prime factors. Now second step is we need to make the groups in triplets of similar factors. Okay, so after making this 9261 9261 is the product of these all prime numbers 3 into 3 into 3 into 7 into 7 into 7. If you multiply again you'll get 9261. So we should write 3 3 as one set. Okay, resolve into prime factors, then make triplet of each number. So 3 number is 3 times and 7 is 3 times. Then cube root of 9261 is equals to 3 into 7. So one number only should take. That is 3 sevens are 21. Fine, 21 is the cube root of 9261. So this is the way we can find out using the prime factorization method. I'll give one more example for testing a number to be perfect cube or not. Now, because for example, I'm taking a number 2744. Now I need to test this number is a perfect cube or not. So can we write the cube root of this number or not? We need to test. So method is same. Just we need to resolve into prime factors and we'll get the product of prime factorization method. 2744 is divisible by 2. You can start doing prime factorization method first. That is 1372. 2 table 6 12. 1 carry 8 6. 2 table 343, right? Again like previous example now 7 49s are and 7 7s are 49, 7 1s are 7. So finally I can write 2744 into is equals to 2 into 2 into 2 and into 7 into 7 into 7. So we can write this as 2 power 3 into 7 power 3. That is 2 into 7 whole power 3. So 2 sevens are so 14 power 3. So 2744 is 14 power 3. So 14 is the cube root of 2744. So we can make by testing whether the number is perfect cube or not also. We need to use only prime factorization method. Similarly, we can say show that some number is not perfect cube. Show that some number is a perfect cube or not. So in this type of examples also we'll take similar. I'll write the question. Show that 648 is not a perfect. So we need to test, we need to show this is not a perfect cube. Taking question big size. So number is 648. We have to show this is not a perfect cube. So is the method is we should take a prime factorization method first. 648. We'll resolve this into factors, prime factors. That is 2 table 3, 2, 4. Again 2 table 162. 2 table 81. Now it's divisible by 3. 27s are again divisible by 3 9s are again 3 3s are 9 and finally 3 1s are 3. So now 648. So 648 I can write product of these all numbers. So 2 into 2 into 2 is one set into again 3 into 3 into 3. Extra one more 3 is there. So this is another 3. So it's clearly 648 is not a perfect cube because some extra number. Everything should be like triplet. So same number should be 3 times to say it's a perfect cube. Now 2 is 3 times, 3 is 3 times and extra one more 3. But 3 is 4 times. So clearly it is not perfect cube. So it's not a perfect cube we can write. Some other questions which are related to the cube root. For example, find the smallest number. Find the smallest number by which 1125 be multiplied so that the product is a perfect cube. Okay, so this is the question now. Find the smallest number by which 11 and 25 be multiplied so that product is a perfect cube. So what number is the which need to multiply to make this perfect cube? So take 11 25 and start make resolve into prime factors. So it's divisible by 5. 11 25. So it's 5 table and same time 2 table or 3 table also can take. So starting with 3 table you can take 3 because it's divisible by 3. First prime number is 3. First prime number is 2, but 2 is not divisible with this number. So next to 3. 3 5 is a 5. How much you can take? It's 11, 25, right? So 3 threes are 9, 2 carry, 22, 7 is 21, 5 is 15. 3 table, 125. Now 5 table, 525 is 5 5 is 25 and 5 1. So 1125. I can write 3 into 3 into 5 into 5 into 5. So if you observe here, how much part is less? Now 5 into 5 into 5 is one set. But 3 into 3 into 3. So only two numbers. So we need extra one more place. Should be 3 here. So additional 3 we need to multiply. So it's clearly, to make it perfect cube, it must be multiplied by 3. So which is the gap which is less? That one number only we need to multiply to make it a perfect cube. So we can say that number also, right? If take 1125 into 3, 5, 7, so 3375. Nothing but this is a perfect cube. You can test. Okay, this is the question what we need to multiply so that to perfect cube. Now some questions they'll ask what is the smallest number we need to divide. Okay, I'll give you one more question. So what is the number we need to divide? Find the smallest number by which, okay, question I'm taking 8788 must be divided so that the quotient is a perfect cube. Yeah, it's clear. So what is the smallest number by which 8788 must be divided so that the quotient should be perfect cube? This is the question. So we'll take 8788, start with the prime factorization method to resolve this number into prime factors. Take 2 table. I'm doing directly 4, 3, 9, 4, 2, 1, 19 is 9, 7. Now this 2197 is not divisible by 3, 5, 7 and 11. Next 13. It is divisible by only 30 table. 13, 169, sir. 13, 13, sir. Fine. So 8788 I can write 2 into 2 into 13 into 13 into 13. So 13 into 13 into 13 is already one set. Now this is extra, which is extra that if we divide, then it become a perfect cube. So clearly, to make it perfect cube, it must be divided by 2 into 2. That is equals to 4. Okay, if you divide with this 4, then the remaining is a quotient is nothing but 13 into 13 into 13. That is obviously 2197. Fine. So this is the way we can find out what number should be multiplied or divided. Next we will see how to find out the cube root of fractions, the same time decimal numbers also.
So students, I hope you all have understood the content. So there is a small assignment based on it. Please try to solve it. Thank you.